Hi, everybody. Thank you for coming to this Energize Connecticut webinar. We want to thank the sponsors of Energize CT, Eversource, and Avangrid. This is in collaboration with Build Green CT and Connecticut Passive House, which is a community within Build Green CT. And we want to also announce that we have some upcoming webinars in this series coming up. On May 19th, we have emergent high performance glazing technologies. And on June 9th, we have pushing boundaries, applying FIA's core to internal load dominated buildings. And all of those are eligible for CEUs, and I will put the links in the chat. I will hand it over to Keegan to introduce this session.
Yeah, thanks so much, Sarah, and thanks everyone for joining us today. Sarah said my name is Keegan. I'm with ICF, and we are the vendor working on behalf of the sponsors of Energize Connecticut to bring this Passive House and Electric Homes training series to you all. These trainings are at no cost, thanks to the sponsors of Energize Connecticut, and are part of a partnership with Connecticut Passive House and Build Green CT. Today's training, as Sarah said, will be recorded and made available online afterwards. And as a reminder, as part of this training workforce development initiative, Energize Connecticut also offers a 75% cost reimbursement for individuals pursuing either FIAS or PHI professional accreditation. This includes the cost of the trainings and the exam, and once you become certified, submit your application and we will process the 75% cost reimbursement. Jeremiah, if you want to go to the next slide. In addition to the no-cost educational training series and professional accreditation reimbursements, the sponsors of Energize Connecticut also offer robust incentives for builders and developers who choose to go all electric with their residential buildings or pursue Passive House certification in multifamily projects with 5 or more units. The Passive House incentive design is shown on the screen here, and it includes pre-construction incentives for feasibility studies and energy modeling, and post-construction incentives up to 100% of the cost of full Passive House certification, capped at $1,500 per dwelling unit. Next slide. The all-electric and high-performance certification bonus incentives are for both single-family and multifamily buildings. There are 3 incentive tiers that projects can qualify for with different performance criteria for each, and incentives ranging from $1,500 per multifamily unit up to $12,500 for single-family homes, in addition to adder incentives for high-performance heat pump equipment and certifications such as Energy Star, LEED, and DOE efficient new homes program. Our goal ultimately is for everyone involved in the construction of residential buildings in the state of Connecticut to be aware of and taking advantage of these incentives. So if you're interested in learning more, please visit our website or contact us at the information on the slide. Couple logistics about today's session. You can communicate questions to Jeremiah throughout the session using the Q&A feature. And as Sarah said, this session is approved for AIA HSW CEUs. And with that, I'll introduce Jeremiah. Jeremiah Bollengier is a sales and application specialist with over 14 years of experience at Broan NuTone, holds a bachelor's degree in industrial design, and brings a strong technical and design-focused perspective to residential ventilation and air quality solutions, and has successfully completed certification to become an energy rater and is a recognized building science professional. So Jeremiah, with that, I will pass the mic off to you.
I appreciate that, and I appreciate everybody for taking the time out of your busy schedules to listen to me talk about ventilation. But indoor air quality is, just more than a job for me. I always like to emphasize that early in my parenting life, my son woke up one morning with an allergic reaction. His throat was swelling up, and I ran into his room not knowing what to do, and rushed him off to the hospital to try to figure some things out to help him be able to breathe. And come to find out, he has a lot of allergies and asthma and things like that, which has really sparked my passion and my desire to learn as much as I can about indoor air quality and ventilation and how to improve it, not just for a job, but for my own personal family. So I do take this very seriously and try to, think of it in the mindset of, how do our homeowners going to be impacted by the choices that we make inside of these houses that we are building for them. So I just wanted to mention that as well. But as I said, this is an AIA certified course. We did submit it through AIA. You guys can also email me if you guys don't have the ability to get the codes or get the credit yourself, and I can add you to my system as well and send you a code to get credit for AIA. You just need to email me so I can get you added to our system for that certification. And the learning objectives for today, is just the necessity for fresh air inside of our homes, and the key components, the key pollutants that impact our health. We're going to review the basic ventilation strategies, metrics, products, optimizing performance, airflow verification, all those things when it comes to ventilation. Understanding the code and the standards that are out there, mainly DUV, dwelling unit ventilation, with inside of ASHRAE. And we're going to explore that in more detail with some solutions and the pros and the cons and of all those different solutions that are available for you, as well as understanding some of the new codes that are upcoming or impacting you guys specifically. So we're going to review all those things today. But the real question is, why are we building homes tighter, right? We're trying to build houses a lot tighter in this day and age because we do have more efficient products that we can do so, as well as we want to be able to control how much money we spent on heating and cooling our houses. So by doing so, we can make these homes a lot tighter, and the whole mindset of build tight, ventilate right becomes more and more appropriate, because the tighter we build these houses, the more struggles we can have down the road. So, but indoor air quality is becoming more and more of a focus when it comes to the need for the better air quality inside these houses because they're so tight, basically. So, but that leads us into the need and how do we test these houses? These houses are built all over the country, have different builders and different contractors, and there's a need to have a standard out there to be able to test and verify these houses. And that is where blower doors come into play. And if you haven't seen a blower door, it basically is a big red door, vinyl apparatus that they put inside the front door with this big blower at the bottom. And they are going to depressurize the envelope of that house to 50 pascals. And my understanding is 50 pascals is supposed to simulate a 4-mile-an-hour wind on all surfaces, exterior surfaces of that house. So they're basically going to shut all the windows and all the exterior doors and all those types of openings and depressurize that house to 50 pascals. So the lower the number, the better. We want to get as tight as possible with inside of your different installation methods for air sealing and thermal barriers and things like that. So we want an ACH 50 as low as possible. With Passive House, with you guys, it's less than a 0.6 is kind of a target that you guys are going after and getting in this house as super tight as possible. There are other standards out there that don't get as strict when it comes to your ACH 50 number, such as the ICC 2021 just has a base of 5.0, which is a lot higher for your compliance path, and 3.0 for climate zones 3 through 8 in the prescriptive path. So knowing what your target is very important, and that's a huge part of teaming up with your energy rater and making sure they communicate what your bogey is. How tight do you need this house to be at that 50 ACH 50. So, but with that, being true, we are now seeing a huge improvement across the country when it comes to tight houses, because now we're able to quantify it. So we're seeing this movement across the country with building tight houses, and we're able to document it and see where these tight houses are. Obviously, it's getting the lowest up north because it's colder, things like that. But it's a huge improvement over decades past when it comes to how tight these houses are. Um, but there are some downsides to building a super tight house. Now we are trapping pollutants inside of our homes. So that's where the need for good ventilation comes into play. We are trapping excess moisture. We are trapping particulates, especially PM 2.5. We are trapping different gases, whether it's cooking gases, natural gas, propane, all those type of things, depending on what we're using inside of our homes. We are trapping, carbon dioxide, odors. I call it the Costco effect. You can buy everything wrapped in plastic and we bring it inside of our house and then it off gases inside of our home. And now we need to deal with that. You wouldn't believe how many times I get called to a job site where they have a fish tank inside of their house and they're wondering why they're having excess humidity inside of their home because they basically have an aerator of water, being put inside their house. So it's really funny how homeowners don't understand the impact they have on the air quality inside of their homes. But we definitely need to focus on that and make sure we identify those things because if we do, then their house is going to have the best air quality possible. We're also finding, there's a benefit to having a super tight house, especially when there's poor air quality outside. Because a leaky house, air is coming in wherever it wants to, from different, cracks, crevices, door jams, windows, things like that. Well, now with a super tight house, we can control where and how that air comes in. And then with that, we can also filter it. So by scrubbing that air, now we can control the quality of that air before it's introduced throughout the entire home. So this is a huge benefit of having a super tight house and controlling where and how that fresh air comes into the house, right? But then also a byproduct of that is now we have depressurization. So depressurization becomes a concern because we're basically living in this tight envelope and we have other exhausting appliances inside the home potentially, not so much with passive house because some of the requirements that you have with passive house. But in general, if we do have any other exhausting appliances and openings to the outside, depressurization becomes a focus or a need to focus on that, where there's some other codes out there where you need to provide makeup air for range hoods over 400 CFMs because we don't want to backdraft an atmospherically vented hot water heater or some other atmospherically vented appliances. I've also seen fireplaces, wood burning fireplaces start backdrafting into the home because of super tight house and they turn on a bath fan or a range hood and now that nice wood burning fireplace, all that smoke and soot comes rushing into the house. So how all of these systems are built on top of other systems is really important to think about when we're constructing our homes and making sure that we identify any of these risks or challenges that we have that can impact the air quality inside the house. So, overall, building a house really tight is a good thing because now we can really control and or lower the overall cost to heat and or cool that home. But we also need to keep in mind that, we need the right mechanicals. We need those mechanicals that are going to provide, the best air quality possible, can ventilate, appropriately and so forth without having impact on the indoor air quality as a whole. But with that, we also need a governing body to verify and certify these appliances. And that's where HVI comes into play. So HVI is an independent third party where they certify and test, all ventilation products across the board. Many different manufacturers provide them products to test and verify and certify all of the attributes of those products, whether it's airflow through your CFM, zone ratings, watts. There's also ERV recovery efficiencies that they look into and verify as well. So they are, again, independent third party that test everything and make sure that we are held accountable to the all the performance that we say our products will perform at. They do have an online tool or directory that you guys can access just at hvi.org, and it will list out all of the manufacturers and our model numbers, as well as the different specs that fan has. So they're a great resource and a tool for you to use and or see to make sure that the product that you are installing is going to work, is going to perform as you intended it. Because you spent all this money and resources into this product, designing it, laying it out, making sure it's in the right location, and then all of a sudden it doesn't work right. That's going to be a huge challenge, a huge problem. So we want to make sure that these fans are HVI certified and tested. And also a part of Energy Star is another excuse me certification platform that is out there to help improve these mechanical devices, right? So they want to have better quality than just code standards out there. So they're out there to assist and help us produce better quality products. So you're going to see some fans that are going to be Energy Star certified and other fans that aren't. So their product criteria basically is any bath fan up to 89 CFMs needs to be 2.8 CFM per watt. If that fan is between 90 and 200 CFMs, it needs to be 3.5 CFMs per watt. There's also one for inline fans, as you see there, where it's no filter, it's 3.8, MERV 6 to 12, 3.6, MERV 13 plus 2.9. Range hoods have 2.8 CFMs per watt, but there's also requirements for zone levels. They want to make sure that it's not super loud. So the max zone that fans that are Energy Star certified is going to be 2 zones. So this is, again, just another certification process that we go through to make sure that our fans are HVI certified, Energy Star certified, and so forth, to make sure that they're going to work and that our homeowners are going to be happy and pleased with the performance of that unit itself. Static pressure is a struggle with all ventilation products as a whole. So if a fan has just a standard AC motor, it can slow down from what we have specified it at. So the industry average or standard from HVI is testing at 0.1 inch of static pressure. So as you see here on this chart, we got 0.1 inch of static pressure. This fan is 80 CFMs as tested by HVI. We have found over the past few decades that installed performance versus testing performance is not always the same. So we found that the national average when it comes to static pressure is 0.25. So you're going to see a lot of spec sheets that are going to articulate 0.1 inch static pressure at 80 CFMs, as well as what is the 0.25 inch of static pressure. And in this case here, it says 60 CFMs. So that's your AC motored, standard motored fan. So the higher that pressure, the lower the performance of that fan could be, or potentially. There are attributes to that, how big the ductwork is, what type of ductwork do you have, rigid versus flex. So ideally we want as smooth and as straight as possible, as well as short as possible. That will help improve their static pressure. and so forth when it comes to these fans. We do keep in mind that the tighter the house, the less infiltration we have. So it can, over a long period of time, also impact the performance of that fan, depending on how long it is running. So we have found through some passive houses, if you are exhausting to the outside, if a bath fan is running only for a short period of time, yeah, you're still just going to depressurize the house slightly using the cubic volume of air that is currently available. But if it's running for a long period of time, then that fan is going to struggle a little bit to bring in fresh air through the existing cracks and crevices that are there. So that's where most of the passive house projects that I've got involved with, they keep outside penetrations to a bare minimum, and they're exhausting the bathrooms through an ERV and so forth, which we'll talk about later, because we're bringing in fresh air as well as exhausting the stale air at the same rate of speed. So, but there are some other products out there, such as bath fans with DC motors or ECM motors, where, as you see here, we have a rise of performance with those motors because they can compensate for static pressure. So we have, with the smart DC or ECM motors, a range of RPMs that we can set these fans to, because we have basically an onboard computer inside of these fans. Who would have thought years ago we'd have a computer inside of a bath fan? I know I wasn't thinking that, but we do with some of these ECM motors, where we can set different RPM rates at specific voltages. And if it's not meeting those RPMs or those voltages, it automatically adjusts to drive that CFM. And that's all pre-programmed automatically built into that fan itself. So you will see some of your charts where it'll be a straight vertical when it comes to performance as that static pressure rises. And that's because of the smart DC or ECM motor that's built into that particular fan itself. So again, static pressure is something that we need to be mindful of, and purchase and install the correct product that's going to hit the CFM that you need for that project. So now when it comes to local and spot ventilation, there are some standards and minimums that we do need to keep in mind overall. And most of them are pretty basic and simple, like bathrooms and toilet rooms need a minimum of 50 CFMs delivered to that bathroom. And no longer can we use 3-inch duct for these bathrooms, because that was the standard for the longest of times. Now we need 4-inch ducts for all these bathrooms. And then kitchens, we need a minimum of 100 CFMs delivered into the kitchen. So these are just some standards that are out there, but these are just the minimums. And this is where HVI comes back in to help us because minimums aren't always good for indoor air quality, right? So HVI now has recommendations when it comes to how do we improve the indoor air quality inside the home, not just these bare minimums, where they have, your bath fans, if it's up to 50 square feet, is 50 CFMs is just fine. If you're 50 to 100 square feet, we need 1 CFM per square foot. If we're over 100 square feet, these grand master bathrooms that we have now, that's basically like a room into itself. We need basically 50 CFMs per fixture and or 100 CFMs for a jetted tub. And I also throw in there those car wash showers that you see, where they've got the jets all over the place and they're pumping all these gallons of water, hot water into that bathroom, and you're going to be hit from all sides with this, these jets and so forth. So I would make sure that we are, over ventilating for those situations with all that humidity. When it comes to your kitchens, we have it split into two, basically conventional cooking and professional cooking. And your conventional, just everyday, us people just trying to cook for our families, it's basically 100 CFMs per linear feet of cooking surface. So you got your cooking stove, and let's say it's 36 inches wide, then we need to have, 300 CFMs for that scenario because it's 3 feet, 36 inches. But if you're doing professional cooking where you have your cook surface, including the oven and so forth, where you have high BTUs, we basically have 100 CFMs per 10,000 BTUs. For example, if you're at 50,000 BTUs for the entire cooking surface, we need to be at 500 CFMs for that. So just keep that in mind when selecting your cooking surface, because are they really going to be using every single burner and all these griddles, and now they're putting grills inside of these cooking surfaces. We got to be mindful of being able to capture all these contaminants and getting them out of the house as effectively as possible. So that's where being mindful of how many CFMs we need for that cooking surface and BTUs is important. So again, this is HVI. All this stuff is communicated on their website as well. If you want to fact check me, by all means, jump on hvi.org and they'll have all this information there as well. So ASHRAE, with these new codes and all these changes, has come out with dwelling unit ventilation, which is also whole house mechanical ventilation. And these standards and codes that they have produced over the last few years are there to ensure that we have good indoor air quality for these homes. As we indicated earlier, super tight, we need to make sure that we're ventilating right. So we need to be removing stale air, get rid of the stale air, and bringing in fresh outdoor air as effectively as possible, because stale air, stagnant air is really unhealthy and not good for us. So there's different calculations and standards that they've produced, but I also, try to emphasize that, there are states out there that have lower requirements, lower versions of the code that they still are, running off of. They haven't adopted the most recent codes. So all the time that I'm consulting with builders and engineers and so forth, I always say, hey, let's make sure we double check with the local municipality and the code officials as to what are they working off of, what is their minimums and standards and so forth, and making sure that we're above that. Because if they're working on a state that has a max zone rating of 1, because they added an amendment or a different changes to the minimums and or maximums, we need to be aware of that. So talking to your code officials is really important and crucial. But some of the basics out there that I want to communicate when it comes to ASHRAE 62.2, the 2010 version, which most codes reference the 2010 version. It accounts for 2 components. You got the total volume of air inside the home, plus the number of occupants, people inside the house. So that's what they're focused on, is how big is this house and how many people are going to live in there. And they do have some calculations that they use as their formula to get to that CFM number. So basically, it's 1% of the square feet plus 7.5 CFMs per occupant. And the occupancy, they get the number of bedrooms plus 1, because they're always going to make the assumption that the master or primary bedroom is going to have 2 occupants. So that's how you get your CFM number using the math calculation. So a 2,500 square foot house, 3 bedrooms, using that math, you're going to be at 55 CFMs. ASHRAE does have tables that they produced. Here we show it, and it's always going to be air on the extreme. So as you see here, the same numbers, 2,500 square feet, 3 bedrooms on this table says we need 60 CFMs on this table. So that just kind of gives you a worst case scenario as to, making sure that the ventilation product that you have selected is going to meet or exceed this table in order to pass code and pass the requirements. They are also requiring that your ventilation product be verified field verification is a requirement now where they actually have to test and verify each and every single bath fan and ventilation product. So they have flow hoods and different products out there. So the three main ways you can do that is, your flow hoods. We have a manufacturer design criteria, a website that we use that can, input all of our data. And I'll show you an example of that here in a second. That gives you what your CFM would be with certain duct sizes and duct lengths. There's also this chart here that they've produced and have also put into the code where it shows you what your CFM would be based off of the style of duct, whether it's flex or rigid, the diameter of the duct, and then how many linear feet you can run that duct. As you see here, there's a bunch of X's, which X's are not allowed, and then the NL means no limits. So it'll tell you, based off of I need 100 CFMs using flex duct, and I have 5-inch, I can only go 16 feet. So one thing also to keep in mind is that each elbow or 90-degree turn, whether it's an elbow itself or just the flex duct turning and going 90 degrees, is you're gonna have to deduct 15 feet for that elbow because of the pressure buildup, behind that turn is causing that fan to slow down and not work properly. So we have to keep that in mind as well when using this chart. And then, high rise and multifamily, no requirements in the IMC and IECC commercial exemptions exempts most systems. So there's different, requirements out there for whether it's single family or multifamily. We just got to make sure we're aware of that and that we are designing the system to work properly and then verifying it in the field. There are manufacturers that have on their website a tool that you can use to tell you how long a duct you can have with a specific product. So basically you can put in the model number of the fan, tell you what your design flow rate is, and then your diameter of the duct and the type of duct and how many elbows, and it will tell you at 50 CFMs, how many linear feet you can go. So in this example, we can go 41 linear feet to hit 50 CFMs with the 4-inch flex with 2 elbows. So these are, this tool is available on their websites for you guys to reference and utilize to get a printout of, hey, I can go 41 feet and I'm less than that. So you're gonna meet the requirement of performance for that particular house. One thing I do want to make sure I emphasize is the 2021 to 2024 IRC, IMC codes do require all ventilation fans to be either HVI or third-party certified. Because it's the Wild West out there. We don't know what people are saying or producing when it comes to these appliances, this equipment. We need to make sure that these mechanicals are moving the air that they say they're moving. So all the exhaust equipment and whole house mechanical ventilation fans need to be HVI certified to make sure that they're working properly and providing the air movement that we need inside of these tight houses, because it's becoming a health and safety concern. If these fans aren't working properly and they're not being tested and verified, then who knows the quality of air inside of that home. And we need to make sure that we give these homeowners the best quality life possible. So with that, the dwelling unit ventilation, there are 3 different strategies out there. And the way I kind of always talk to my builders and contractors and engineers about is, if you have like 5 ACH 50 and so forth, yeah, exhaust, the exhaust strategy will work because you're still pulling air from your cracks, crevices, areas of the house that are going to be leaky. through those wall assemblies and so forth. So if your house is still kind of leaky, an exhaust strategy will work just fine using a ventilation fan. If your house gets into that 3 ACH 50 range, and there's a buffer there, plus or minus, and so forth, that is when supply kind of takes over, because it's a snorkel into that house. It's providing a direct pathway of fresh air into that home, providing that fresh air, kind of creating a ballooning effect, and then utilizing the cracks, crevices, and so forth inside the house to push that fresh air out. There are, different exposures to risks with all these solutions, and I'm not going to get into all that today. But just, again, be mindful of the impacts that you're having by putting positive air as well, because now you have the risk of putting hot, humid air into your wall assemblies as you're pushing that air out of this potential balloon, right? And is there a risk associated with that? Or we have balanced strategy, which is preferred, but it's the most cost, right? Both product cost as well as installed cost. Where this is, you have, basically an exhaust and supply strategy to balance out that house. So these are the three strategies that ASHRAE references when it comes to meeting the DUV requirements. Getting a little bit deeper into those strategies, the exhaust approach. So this is pulling stellar out of the dwelling, and it's just being replaced in, natural infiltration inside of the home. It is, generally a lower cost to purchase and install this. Also lower to maintain this product because it doesn't have as many moving parts and pieces and so forth that you have to deal with and maintain. There are different models available running at different CFMs and timers and all those type of things that you'd have to make sure that this fan has basically 2-speed operation and can run at a high-low, running continuously at a low CFM, and then we'll ramp up when the occupant inside that bathroom as a high spot ventilation strategy as well, incorporated into this exhaust fan. So but there's a whole bunch of solutions out there, and they do work, just more so with houses that aren't super, super tight. The supply approach works great. I call it a snorkel into your house, where we're controlling exactly where and how that air comes in from. And like we talked about previously, about if we're in like Colorado and so forth, what was it, like a year or so ago, they had all those fires and so forth. We have to worry about those concerns, bringing in that fresh air. So now we can filter it with the supply approach. So now we can add filtration to these so the supply strategy. But there's two basic methods to this supply. So you have a central fan integrated system, a CFIS strategy, where it's just a motorized damper. So it's utilizing the air handler on the furnace. It's interlocked with the furnace, and it will open and close with that furnace, and allow that path of fresh air through this motorized damper, which is a picture on the top. But typically this strategy does require an upgrade on the air handler itself, typically to an ECM motor on that, because it's going to be running all the time or more frequently to bring in that fresh air. Or we do have a dedicated inline fan, where I call it a fan in a can, with all the controls built into it so that it can run for so many minutes an hour, and can also be interlocked with the furnace, and has a built-in filtration filter boxes inside of them to provide that filtration. So these are the two basic methods: the CFIS and then the dedicated inline fan option when it comes to the supply strategy. When it comes to, there's a balanced approach out there utilizing both of those products together simultaneously. So using the exhaust and the supply strategies at the same time, we can get a basic balanced approach, but we don't have any recovery. So it's just whatever air is outside, temperature and humidity wise, is going to be coming in and so forth, and mixing from inside your house. This is great when we're worried about pressure, dealing with the pressure difference between the inside and the outside when it comes to running exhaust fan and so forth, but can be difficult when it comes to we're spending more money for this strategy. If you spend just a little bit more, now we can get some recovery and ROI alongside this balanced approach. But there are different codes and incentives out there that want this balanced approach. And this essentially is the cheapest, easiest way to do that, but not the most beneficial for overall indoor air quality and recovery. But it still does work great for these super tight houses where we need, exhausting as well as fresh air coming in. But that leads me to HRVs and ERVs, which is hands down the best solution out there. But with the best usually comes additional cost associated with it. So this is the balanced strategy with recovery. So there's two types of units. You have an HRV and an ERV. An HRV is a heat recovery ventilator, and an ERV is an energy recovery ventilator. They both will manage temperature, the delta between the inside and the outside temperature, but an ERV will also help manage the humidity levels, the delta between humidity between the inside and the outside. So in my professional opinion, the entire United States is an ERV market because we have this crazy jet stream right now that, pushes this hot, humid air from the Gulf or from down south in Florida and all the way up the coast there, that we do have quite a few weeks during the summer that we have hot, humid air all the way up to the entire United States, in my opinion. Plus, what we have found recently is ERVs also help manage the humidity levels inside of our homes in the winter. So we are installing humidifiers in our houses as well for these winter months. Well, an ERV will help keep some of that humidity inside of our houses in the winter. So we found a huge benefit of an ROI there of not spending as much money humidifying our houses in the winter, because the ERV will help keep it, more humid, or keep the humidity we've spent through a humidifier in our homes in the winter as well. So those are the two main types, and there's different energy modeling and so forth with these different products and efficiencies out there that we have to keep in mind with our HRVs and our ERVs. But overall, an HRV and ERV is comprised of four main components. You got the box, the shell of the unit itself. You have a filter, you have blowers, and you have a recovery. So these are the four main components we have that's inside of all ERVs and HRVs. Besides that, it's a combination of all these parts and the quality of these components that make the quality and differentiate ourselves. One manufacturer from another is the quality level and recovery of these units. But if you don't understand necessarily how an ERV HRV works, this picture here really kind of shows you where you've got your stale indoor air, which is the red, coming through that core going diagonally, and then gets pushed to the outside, which turns into the blue arrow. And you have, which is cooler, right? So this is basically in the winter. And we got the fresh outside air, which is cooler, goes through the core and turns more red when it's introduced into the house. Because we are using the laws of thermodynamics to transfer that energy between streams without cross-contamination using this core. And this is a great slide that I love talking about, the big nerd that I am. Goes over some of the basic physics and understanding of, air is hot to cold, wet to dry, high pressure to low pressure. And we're able to transfer the energy that we've spent to heat and or cool inside of our homes through the surface area of those chutes. And basically I call them straws. So you go to a fast food restaurant, grab a stack of straws, and you're going to have one stack of straws going one direction, another stack of straws going the other direction, and you just keep alternating those straws. And then you basically cut it into a cube. And then, so the air will go through those straws, the incoming air and the outgoing air, without cross contamination. But we're able to transfer a percentage of the delta between the inside and outside air on the surface area of those straws. So this core is basically the heart of your ventilation strategy inside that house. So that's been the easiest way I've been able to explain how an ERV HRV core works. So we don't have any cross contamination inside this core unless potentially it freezes. So if, as we know also with air, that we go from a gas to a liquid to a solid when it comes to moisture and water. So as that air holds that moisture and water, right? So if this core gets super, super cold, that air that goes from a gas to a liquid to a solid will expand inside this core and then could break the core itself. So that's why make sure you select an ERV, HRV with a defrost cycle. But just to give you a quick kind of overview of some of the numbers, this is your sensible, your temperature recovery in like the heating season up in Minneapolis, Minnesota. If it's negative 13 degrees outside and 75 degrees inside, as we transfer that air, it can become 61 degrees, way warmer than that negative 13 that's outside that we would have with just a supply strategy. In the cooling in like Phoenix there, where it's 110 degrees outside and 75 degrees inside. Now that air is 83 degrees versus 110. So less demand on our HVAC equipment. We've actually seen contractors being able to downsize the tonnage of their air conditioners and or don't have to have as high of a BTU furnace by utilizing ERVs in their home because they don't have to have as much rise or lowering of that temperature when you're bringing in that fresh air. And then when it comes to your latent load, your moisture, similarly, it's 12% relative humidity outside in Vegas, and we want it 50% humidity inside. So this will help keep the humidity into the house because it's super dry and hot outside potentially. Same thing with Florida. If it's super hot and humid outside and drier inside, now it's going to help push that humidity out. One thing I do want to emphasize is that an ERV is not a dehumidifier. A byproduct of the air transfer, the laws of thermodynamics is we're going to be able to help maintain, but it is not a dehumidifier. So in some of those extremes, climates such as Florida, having an additional dehumidifier may be a good thing to think about when it comes to really controlling the humidity inside of those spaces. But this ERV will actually help maintain it, but not actually, quote unquote, dehumidify. So there are different metrics when it comes to your SRE, your sensible recovery efficiency. So that's how efficient that transfer is. But your SRE is temperature only. It does not include your electrical consumption. So that's an emphasis we want just to make. You also have your ASRE, which doesn't include the electrical consumption and uses your energy modeling when wattage is separately accounted for. So the ASRE number and the SRE number are two different ones that you got to think about. So your SRE temperature only includes electrical consumption, where the ASRE does not include your wattage in the calculation when it comes to efficiency. And that's where just teaming up with your energy rater and making sure he has the right number and put it into his calculations, his load calcs. But what you'll see through HVI, when they test all of our products, they're going to have different airflow rates and they're going to test it at multiple different CFMs and dictate, is it the heating mode? Is it cooling? What's the temperatures? What's the wattage consumption? And as well as what's your SRE and ASRE. So they're going to have all this data on their spec sheet and documented in their directory on their website for all the manufacturers that are certified and verified out there. So just keep a lookout as to what CFM you're needing and what's your consumption and so forth. And also, some manufacturers even team up with some of these energy modeling programs out there, such as Ecotrope, where all this data is preloaded into their system. So the energy rater literally can put in a model number, and all this data is preloaded right into their system. And so there's no confusion as to how is this particular product going to benefit or have an impact on the performance of that house as a whole. So now when it comes to filtration of the ERVs, you just have your standard, PPI filters out there. But with ERVs, MERV8 is their standard that they're requiring for ERVs. So MERV8 is the standard that gets, your insects, your lint, and all your pollen and your basic, dust and all that fun crap filtered out. But there are many different options out there where you can add a MERV 11, a MERV 13, or even HEPA filters to your unit. So just depending on what option you want to purchase an additional filter to be added to this to that device, basically that mechanical system. The higher the MERV, the more particulates are going to get, like smoke and smog and bacteria and things like that, viruses. Like you're talking about Colorado and those wildfires, having a high MERV is a great thing. So when it comes to ducting these units, ducting for all ventilation products is very, very important. There are some good, better, best strategies out there that I want to just briefly go through with you. The best strategy is fully ducted, and that's where you have all your supply and your returns going through the ERV are independent of the HVAC system, but it's also the highest cost. So we're pulling stale air from areas of contamination, your kitchen areas, your bathrooms, living spaces, but we're putting our fresh air into our bedrooms and places that we're just going to congregate the most. So this is fully ducted. We see this a lot with mini splits, radiant heat, things like that, where there isn't an HVAC system to tie into. So we see this the most in that type of environment. We do also have another strategy called the dedicated exhaust, which is the upper right. I like this one the most. I'm based out of Chicago here in the Midwest, and this is the one that I talk about the most because we're going to have an HVAC system. So let's pull the stale air from the central location inside the home, but let's put our fresh air into the return plenum. So if the furnace is running through its natural cycle, it's going to be finishing the tempering process and equally distributed throughout the house. But if the furnace is off, we're not forcing the furnace to turn on. It's just going to migrate backwards to that return plenum towards your exhaust, but still be inside the air barrier and thermal barrier of the home, providing that fresh air. And then hopefully at some point that furnace is going to kick back on and then grab all that air and temper it and distribute it equally. So I found this to be a good way, a better way of doing it. So a good way is the simplified method where we're putting both our fresh air and pulling our stale air from the return plenum itself. I see this happening a lot in retrofit situations where we don't have access to all the walls and ceilings of the house. The house is already built and we're trying to improve it. So there are weatherization agencies out there that are doing retrofit work, and I see them using this method the most because they don't have access to everything. The challenge here is that the unit will short cycle if the furnace isn't running. So this does require you to tie into the furnace, and the furnace has to be running for the ERV to work. So you do have an energy penalty with this strategy to duct. We're coming to the end, I promise you. So there are some temperature, ERV, HRV temperature testing and certification options out there, and different requirements that they're looking at. Mandatory testing for these, units. Whether it's a heating season performance, very, very low temperature testing, cooling season performance. There's all these different requirements that are out there based off of which program you're in, whether it's Passive House or the DOE Net Ready or EPA's Indoor Air Plus or so forth. So we just got to be aware of what those certification requirements are and make sure that that unit meets those. And that's where, again, HVI comes in and has all these different set points for us to reference and look at. So just be mindful of, what program you're working off of and what are those minimums and requirements they have for those different seasons, whether it's heating season, cooling season, or a really, really cold, like we got up in Canada, we do a lot of products up there, and they got different requirements where it has to be tested to, far, far sub-zero temperatures, and they have to work up in those climates as well. So be mindful of that. So now it comes to some of the code changes and code discussion. IECC commercial, which is 4-story plus multifamily, where dwelling unit ventilation is required now. They are requiring some form of dwelling unit ventilation based off of that 1% of the square feet plus 7.5 per occupant. HRVs and ERVs are required in the prescriptive path, as well as there is entropy recovery rates that you have to be mindful of depending on your climate zone. So keep that in mind. And then there are minimums when it comes to fan efficacy. So that's 1.2 CFM per watt is required for the IECC commercial. IECC residential, which is single family homes and or multifamily up to 3 stories, where HRVs and ERVs are required in climate zone 7 and 8 with a minimum of 65% SRE. But you also have to have one of the 5 additional energy efficient options that must be chosen. And they include, a few different things where it's, improved SEER rating on your furnaces, a tankless hot water heater, air sealing, sealing up the house super tight at 3 ACH 50, an ERV HRV with 75% SRE. There's a whole list of those inside of the manual that you would have to select from when it comes to the additional energy saving method or option you have to abide by. The IECC 2024 commercial changes, basically you got to meet the entropy recovery ratio of the 2021 or meet the sensible recovery efficiency settings here. So they just want to make sure that, we are getting that recovery as best as possible, both your latent and your sensible recovery efficiencies, because moisture is becoming a big focus with these new codes as we build these houses, again, really tight. The 2024 IECC residential changes requirement for HRVs and ERVs in zone 6 through 8. Bathroom exhaust ventilation is required to have a timer, occupancy sensor, humidity sensor, or contaminant sensor. So basically, any bath fan has to have some form of automatic control to turn it on or off. And then third-party airflow verification test not required if the system has an integrated diagnostic tool to measure the airflow. So some of the ERVs and HRVs that are out there will have a digital display that will tell you what your CFM is. And if that product is HVI tested and verified to hit that CFM, then you may use that digital display, that diagnostic tool, as your form of verification, which is a huge benefit to the 2024 code. And then the 2024 IMC changes. Basically, they're going low rise multifamily. You have to use that 3% of the square feet of the living space plus the 7.5 CFMs per occupant. And the high rise multifamily, it is 0.35 air changes, but a minimum of 15 CFMs per person. So these are just some of the calculations that they are requiring now for the mechanical code side of things. And there are also increased continuous ventilation rates for local exhaust. So that's basically saying if you're running continuously out of a bathroom, that minimum requirement, went from 20 CFMs up to 25, and for bathrooms and for kitchens, it went from 25 CFMs up to 50 CFMs for your continuous. So I know that was just drinking from a fire hose, but those are all the different codes and requirements and strategies when it comes to indoor air quality. I know I can get into the weeds pretty quickly with different topics and questions, but just know that I am here to help you and support you if there's any additional questions, concerns that you guys have. I tried to keep this as clean, direct, and simple as possible. But if there is any questions, follow-up questions you guys have, you can email me. All my contact information is on the screen here. Like I stated previously, if you can't get your continuing education credit on your own, by all means, email me and I will add you to mine and make sure that you guys get credit for that. Thank you very much for your time and allowing me to entertain you for the last hour and 5 minutes or so.
Thanks, Jeremiah. We did collect people's AIA numbers during registration. So I added a note in the chat that if anybody forgot, that we, Bill Green CT, will help get you the numbers you need so people get their credits. Thank you for offering to do that. I will we'll give people a minute to put some questions in the chat, but I want to thank you for starting this off with your personal story about why you care about this work. I think it's a great reminder that ventilation is about health. It's not just, getting the numbers to balance. I mean, it can be personal and it's important. So thanks for that.
Absolutely. Quality of life for these homeowners. And they don't even understand the impact that they have. And that's where, I spent the last 14 years diving into this and learning as much as I can. So, and my family benefits from it. So,
yep.
Yeah.
And I'm also curious, since your time doing this work, how are contractors and mechanical installers reacting to this kind of quote unquote new airtight world? Are they embracing it? That might be a loaded question.
A challenging question, yes, because it really depends on their mindset, right? And it's kind of split into two houses, right? You got guys that just love it and they're passionate about it like I am, and they're trying to do whatever they can to provide the best quality air possible and lowering their exposure to risk. A lot of times when I'm meeting one-on-one with contractors or builders, I talk about exposure to risk. There's a lot of different products and different ways to install these products, and each of them have inherent risks, and by system on top of systems can create challenges that you have to overcome as well, or that will reduce the air quality inside the home. So I try to explain all those risks and challenges, and some of the contractors love it and they run with it, and we collaborate and come up with some great ideas. And then you'll have the guys that are just, what do I need to pass code? I don't care. I don't want to think about it. I just want to, throw this equipment in there and get paid and move on. Sometimes those guys are doing a disservice to their builders and or homeowners, but I can't tell them how to run their business and so forth. So you kind of have those two sides I have found over the years. Guys just want to just keep it as simple as possible, just throw it in there and does it pass and then move on. Want no liability, no interaction. And then the people that do care and they want to provide the best quality air and the best product and installation they can. So, but it's slowly changing to people get it. People are, with the code changes I just mentioned, they're slightly being forced to learn and forced to provide better products and then learning it along the way as well. So,
Mhm. So we do have two questions.
mhm.
One is, does the airflow value for an exhaust fan account for a tight house?
So yes, I did see this question, and I tried to add it into my explanation earlier when I talked about, you know, having a bath fan with static pressure, right? We talked about static pressures, and a super tight envelope will reduce the amount of infiltration that the house will have as a whole. So the fan could slow down or struggle hitting that CFM number if there's not a available air. So if it's only for a short period of time, the cubic volume of air inside that virtual balloon is still enough to get rid of that humidity out. But if it's running for a very long period of time, well, then yeah, it's going to struggle and it can slow down as well. But it's tough for HVI to indicate or test for that in their facility. So they don't know what ACH 50 in performance is, so there's not going to be a metrics for them to document that specifically, but it will and or could have an impact on the performance of that tight house. So hope that answers your question.
And the next, excuse me, the next question, do you make fans for solar walls that fits within a stud wall, just 16 inches on center?
For solar walls, I guess
Yeah.
that's,
If
I don't guess I don't
Thomas,
understand.
if Thomas is still on, feel free to unmute yourself to chime
I
in.
know we do have fans that will fit inside of studs, inside of walls. Because you're more worried about the depth, So we do have fans out there that are 4 inches in depth and can fit into a 2x4 wall, and they're designed to run vertically versus horizontally. So depending on um, that installation method, we do have those options. One of the things that where my brain just went, building science thinking here is sometimes if he's talking about an exterior wall where now he has to have insulation around it. I guess depth also plays there as well. So is it a 2x6, 2x8 wall that has insulation that a low profile fan can fit into while still allowing for insulation around the housing itself? There are ways to install in that method if that's what you mean by solar wall, where it's getting UV heat. Maybe it's a southern facing wall assembly that we still need to insulate and air seal and have a thermal barrier inside of, as well as ventilate. There are products that are lower profile that can fit inside of there and still provide the best overall UA value. Of that wall assembly as a whole. I think that's kind of where my brain is going on that question. But again, my email address is here. I am happy to discuss this in further detail at another date or time, and here to support your attendees with anything they have when it comes to ventilation as a whole. So it's really expanded so much over the 14 years. We just went from just basic bath fans, ventilation fans, to now supply fans and ERVs and HRVs and dehumidification, and all these things are all tied together now, and they all need to have different performance ranges up and down when it comes to CFM and recovery and all these things. So it can be very overwhelming and complicated to understand, and that's where we at Broan, we have a whole team of professionals that are here to support you guys. And if it's not me directly, we have people in across the country that can help you and even do on-site work and meet you on a job site if needed. So, any other questions that we have?
No, otherwise it looks like you did a terrific job and answered everybody's questions during your presentation. So
Awesome.
thank you very much.
Well,
Keegan,
I appreciate this
send us out?
opportunity. So
Yeah, Jeremiah, thank you so much. Sarah, thanks for your help, and to Build Green Connecticut for their continued support. And yeah, just thank you to the sponsors of Energize Connecticut for continuing to support this initiative. And as we said off the top, we've got another great session coming up on May 19th, Emerging Solutions in High Performance Glazing, and another on June 9th. And that will be, forgetting the exact name, Sarah, do you have it?
It has to do with FIAS core.
Vias
And that,
Core,
yeah,
yes.
and that program is FIAS approved for a credit.
Yes. Pushing boundaries, applying Fias core to internal load dominated buildings. So pass file specific on that one. So hope to
Mhm.
see everybody there. Thanks, Jeremiah. Thanks, Sarah. And hope everyone has a good day.
Great. Thanks a lot.
Thanks. Bye.
Bye.